Let's see if anyone's actually here this morning. Happy Saturday. Check out my Founders Fund jacket. So yeah, there was no stream last weekend. Whoa. Subs are better, people. But don't trigger me this morning because we got real shit to do today, okay? Got real shit to do today. No triggering. We got to go to sub mode right now, actually. And congratulations, Sarah99. You're the reason. No, I didn't buy a damn. I found a lot of... don't get me started on that. So you're really trying to trigger me this morning. You're really all trying to trigger me. But we can't get triggered because we got stuff to do today. So, let's see. I talked with Carpathy last weekend. And wow, Obelix, wow. Thank you for gifting subs. Your choice of who to gift the sub to, I might question a little bit, but you're all right. All right. So I was talking with Carpathy last weekend. And, you know, he's obviously a very smart person. And he's like, yeah, George, I try to watch your tinygrad tutorial videos. And what happens in your tinygrad tutorial videos is you start out trying to explain things, but then you go off on absolute tangents and go start fixing bugs and go doing things that are unrelated to the tutorial video. And none of this makes sense even to me. So I'm like, if I'm not even making tutorial content that Andre Carpathy can watch, what hope do the rest of you have? So we're going to really try today. And if I go off topic, I need you all here with me paying attention. And if I start to make no sense, I need you to be like, George, this shit doesn't make any sense, okay? We need everybody. This is a team effort today, okay? All right, so everyone I'm sure is familiar with a UOP, a JIT, a tensor, what graph compilers are. No, see, that's the problem. We're going to start... Yeah, he's absolutely right, okay? We're going to start with absolutely nothing. Okay? So we're going to create a new file called ramp.py. And we're going to try as hard as we possibly can to keep everybody even. Everyone who's a subscriber, we got to make a bar somewhere, okay? We got to make a bar somewhere. So these are the tinygrad docs. You can install tinygrad with that command. All right, great, we've installed tinygrad. Step 1, increase font size. Thank you, because we need empathy today, okay? We're gonna make the font size big, because if I can't teach you guys with a big font size, what hope do we have, okay? Is that a good font size for people? Can everybody see? Is that a good font size? You know if the font's big, I'm really trying, guys. Can you teach us React Native? Get out of here. Okay, we're really gonna try. You know. Have you heard of No Child Left Behind? Oh, that's a bullet. No. We're not getting. No Child Left Behind is a great sentiment by a brilliant man. No. I'm triggering myself here. No, we gotta stay focused, right? Right, a brilliant man, George W. No. It's not worth it. It's not worth it. We gotta stay focused. Why do I care about teaching others? Oh my God, yeah, I'm like that teacher who you just like. All right, and today we're gonna finally get around to that quiz. But Mr. Scarpone, could you tell us about that time back in high school when you were? Oh yeah, that time back in high, and then that's the class, right? You know. All right, meditation time. That's a good place to start. Let's start with some meditation, all right? Yeah, I know. Those are the best classes. You really learned some shit. No, I had this great teacher, Mr. Weems. Oh, yeah, you're getting me. I had this great teacher, Mr. Weems. Mr. Weems told us about this one time when he worked on this boat, but it wasn't like a real boat because you couldn't drive it places. It was always anchored. And this lady asked where the exit was, and he was like, well, yeah, where are we now? You gotta wait. You gotta wait for it to come back. And she's like, okay, all right, let's take a minute and find some peace.
Close your eyes, and we'll take a few moments to calm your mind and body.
1 minute is too short. This is too short of a meditation. You can't meditate in 1 minute. We need 2. Now we're talking.
Hi, I'm Rosalie, and welcome to this 2-minute meditation.
You think she's hot?
Find a comfortable position and allow your eyes to blink closed. Now take a deep breath in and let it go with a sigh. And again, deep breath in and sigh it out. Breathing in again. And as you exhale, let go of any worries, any concerns, any niggling thoughts. With every exhale, allowing any tension to melt away from your shoulders, your neck, your jaw. Just for this moment, letting go of any worries, any concerns, knowing that you can always come back and take care of these later. Now settle into this space of ease and comfort, where there's nothing to do except to relax and enjoy this feeling. And it's time now to come fully back into your body, feeling relaxed, serene, and ready for whatever lies ahead. Namaste.
All right. I'm coming to you from a place of empathy. You are First Officer Blunt, and I am Captain All Ears. First Officer Blunt speaks what's on his mind, and Captain All Ears listens and tries to understand. Yeah, we'll come back to that video if we need it. It's a good video. Okay. I'm going to put chat down here because I don't need you right now. Okay. So we've pip installed tinygrad. It's very easy to work on tinygrad while you're using tinygrad, and before 1.0 it's kind of encouraged to be used like that, but it is fully usable. It's just a library where you can install it and don't have to think about it. But we still recommend installing from master. It's easy to you can just git pull in that directory. So maybe we should start with the concept of a device. So from tinygrad import device. And we can print device.default. Tinygrad auto detects the best device on your system and makes it the default. Okay. So we have a device. This device is called metal. Now, let's create a tensor. This tensor has not been computed yet. Okay. The lazy data property on tensor contains the chain contains the specification of how to compute it. as you can see, it's specifying copy from the Python device, which is where the array lives. Very chill stream today. We're doing simple tutorials. You're off camera if you go over there too, by the way. So you can see that this is a buffer on the Python device. This arg4 means that it has size 4, and it's just the 0th buffer because buffers are unique. UOPs are the core, or the specification language in tinygrad. They are immutable and form a DAG. They have an op, a dtype, a tuple of sources, parents, and an arg. All right, so everyone see the uops, ops, dtype, arg, source. You can see that source is like this buffer uop has a unique and a device as a source. We want to realize a tensor we can with the realize method. Now, when we look at the lazy data, it's changed. Copy was actually run, and now the lazy data of the tensor is just a buffer. If you run with debug equals 2, this script with debug equals 2 in the environment, see the copy happen. Okay. Does this make sense to people? Let's check in with chat and see if you guys are following. Ice Leo, thank you for gifting subs. Do duplicate calls do realize throw exceptions, or is it a no-op? So we can get to what duplicate calls do in a minute. Now let's do some compute. T times 2 equals T times 2. it's interesting that const has a view now. From above is being multiplied by see, and now is when I don't like the way this shape tracker printed. Expanded, it's reshaped and expanded to broadcast the const to the buffer. The lazy data to see the specification. UOPs are both immutable and globally unique. Multiply tensor by 4 twice, these result tensors will have the same isn't just the same, It's the exact same Python object. Okay. Does this stuff make sense to people? We've done some very basic. Like, is this readable? If two UOPs have the same source? Oh, it's like deduped. You can try it. Yeah, it would only compute t equals 4 once, right? If we realize oh, I don't have the output for that? Yeah, I should. You're right. Cool. Great. So you can see that in between there's only the copy. The compute is done up here. Right, you can see the compute. Match operations, very little. Very little. It's so you can. It's simple how it works. It's a global cache. So like we have a meta class here, which does the deduping here, and it just checks to see in this ucache if it matches, and if it matches, it just returns the existing one in the cache. And it's done op by op, so it's extremely fast. Okay. What should we do next? Like, that gives you a basic understanding. I think maybe next we should play with the graph rewrite engine. what's above gives you enough of an understanding to go use tinygrad as a library. Maybe we should just do a maybe put why using tinygrad makes sense over other libraries. So I don't like doing things like that, and not to go off into the weeds into like philosophy, but I'm not trying to tell you why tinygrad is right for you. That's what advertising is. That's a form of manipulation, and it doesn't go anywhere. It's a race to nowhere. It will end up with, okay, we're not going to speculate too much, but my point is we don't do that. I'm not trying to sell you on using tinygrad. I'm trying to tell you what tinygrad is. The best I can do is tell you what it is so you understand that. And then you fundamentally have to make your own decision about whether you want to use it or not. So, I explain this philosophy to people, and people think that I will lose because of it. And if I do lose because of it, well, so be. Because the minute you start doing the other thing, you've already lost. You've lost the minute you started playing. Because that will end up only with everybody. People in general don't make good decisions. They like being sold something shiny. So, do you know the parable of the Chinese farmer? There's a Chinese farmer, and his son breaks his leg, and everybody in the community is, oh, that's so terrible. Oh, your son has a broken leg. He can't go work in the field. But it all comes down to time horizons, because a month later, the conscription officer comes around and drags away all the young men to go fight in the army. And the son with the broken leg doesn't have to go because he has a broken leg. And then all the townspeople change their tune. Wow, it's such a blessing that your son broke his leg and he didn't have to go off and die in Mongolia. So it comes down to time horizons. People might like being sold something shiny over a short time horizon, but if the world continues trying to just sell shiny things to people, the people who fall for the shiny things are going to end up wire-headed. If you don't retain an ability to independently evaluate, it will be a complete ratcheting up until very powerful forces have entirely manipulated you. If you've played the paperclip game, it's like the hypnodrones. So the parable of the Chinese farmer shows that what is preferable in the short term may not be what's preferable in the long term. And I'm a man of God, and fundamentally you have to have faith in human nature. Because if you don't have faith in human nature, well, I don't know what to tell you. Do you think that the manipulators have your best interests in mind? And of course they don't, because manipulators with your best interests in mind will lose in a competitive manipulation game to manipulators that have only their best interests in mind. tinygrad also has an auto differentiation that operates according to these same principles. This would require me to more deeply understand how. I don't actually really understand like what gradients do. So what's the derivative of exp? What's the thing with like the simplest derivative? It's the derivative of like log 2. I mean, that's not anymore. Yeah, okay, so the derivative is 1 over x. Is that true? It's also not going to work because no floating points are actually like accurate. Due to how the log is implemented, this gradient contains that should actually be able to cancel out. All right, and now we're off. And now we're off on the tangent where we go and fix things. All right, so that should cancel out. Run. If debug equals 4, you can see the generated line of code. You're concerned on shipping internationally. We ship tiny boxes all over the world. I mean, like, I want you to, like, think that through and think about where your concerns really come from. So, like, obviously, if you buy from us, like, I'm not going to ship you a bunk box, right? So sometimes I feel that, like, in general, tinygrad, you can email support@tinygrad.org and you get no reply. Anybody who has a custom request, completely ignored. My philosophy about this stuff is that there's maybe like 20 or 30% of customers who are looking for more of a support experience than we want to provide. And I've realized that mostly what they're actually looking for isn't anything concrete. They're just testing to see if there's a person available who will care about them. And my response to that is no, there is absolutely not. There is not a person here who you're going to be able to talk to about any of your concerns. And if that's the kind of thing you're looking for, you should purchase from somebody else. Now, like, I don't believe that that's a real concern. Because obviously you can click Australia in the menu. I put a lot of thought into designing that menu, thinking about what countries we can ship to. And like, it's not like the box isn't going to show up or it's going to be damaged. That's obviously on us. So yeah, I mean, if it's a genuine question, yeah, of course, we ship these things all over the world. We ship multiple out every week. But if it's I'm probing to see if there's somebody here who cares about me, the answer is no. Well, I'm not going to keep all output in those comments. Wait, you want me to put this one in the comments? Okay, I guess, yeah, it looks kind of cool. Fine. is in how easy it is to interact with the internals. No, this stuff. The APIs for... No, it compiles to C. That's compiled. That's actually a metal kernel. And I can also run with like CPU equals 1, and that's a C kernel. I mean, the other thing that I would say about that is you can, everyone who wants any sort of like support or any kind of interaction with us, they have to come into the Discord. And you can read the Discord scroll back. You can see a whole bunch of people praising the packaging. You can see one guy who did get his packaging, whose the packaging was damaged when it arrived. He rejected the package. It was sent back to us, and we sent him a new tinybox. We get full insurance on all of these things. We got our money back from FedEx, not just for the shipping, but I think we actually got quite a bit for that box too. Looked like a guy drove a forklift into the side of it, and it was damaged. But yeah, that was one, and maybe sold a bit over 100 boxes now. The APIs here are subject to change. So we should kind of put some effort into making these print better. Hello.
Would you like some lunch? I was gonna order.
Ooh. Look who it is.
Oh, it's you. The camera's here though.
The camera's here.
Hi.
What are you getting for lunch? Are you going to... Oh, you're ordering from Tender Greens?
Do you want tender greens?
I never want Tender Greens.
It's not good?
It's not that it's not good. It's that it's like sweet green. And in general...
I love sweet green.
I know, but if they have green in the name of the restaurant, in general, it's food for rabbits. And you know, if I have that, if rabbits eat it, that I don't.
It has salmon, steak.
No, I understand, but if rabbits eat it, I don't. Because you just think about a rabbit and you ask, do you want to be the rabbit?
We're all gonna become rabbits.
Not me. Many people might become rabbits. I think people who fall for shiny objects might become rabbits. We gotta talk about shiny objects. I told them the parable of the Chinese farmer.
Would you like me to order you something for lunch?
What are our options? Are they only from Tender Greens?
If there's something else you want, we can order something else.
So the food that I like to order, there's a great Chinese place.
Is it this one?
No, I've never seen that one before. There's my usual Saturday food. So the good Chinese is along Convoy Street. What is Skinge Chekwon? Tasty Mandarin? What is this? Do I have to spell Chinese right?
So you told them the parable of the Chinese farmer.
I told them the parable of the Chinese farmer, yeah. Ooh, I mean, Din Tai Fung is very good.
That looks great.
Oh, what Din Tai Fung is delicious. It's going to take a long time. It has a moderate... Oh, Shanxi Magic Kitchen. This place.
Okay.
This place. Sauté spicy chicken with hand-pulled noodles is my favorite.
Great.
But you'll be happy with that stuff. It's good food.
Great.
And it's pretty healthy, too. It's like... It's real, like it's like real Chinese.
Good. All right. What are we talking about today?
We're doing a tutorial. So Karpathy told me that we need a ramp because tinygrad doesn't make any sense.
What do you mean it doesn't make sense?
Well, I start these tinygrad tutorial streams and then I just go absolutely off into the weeds. And we're really trying to stay focused on this stream.
All right.
So, yeah, does this make sense?
In a galaxy far, far away, we start with a device. A device is where tensors are stored and compute is run. tinygrad auto-detects the best device. That part makes sense.
Okay.
Which is the part you're concerned about not making sense?
I mean, I'm not sure. I'm not concerned about any specific part not making sense. It's more just like tinygrad's just confusing. I don't really know.
And that was Karpathy's feedback?
Karpathy's feedback was every time we try to do a tutorial to tinygrad that it doesn't make any sense. I mean, I guess, like, I don't know. I don't know. I don't know what people are really looking for. Like, there's a lot of people who just want, I just want to, like, use this to do something, and I don't want those people. The beauty of tinygrad is that you can actually, like, understand it and change it. But it is getting confusing, which is another problem. And then I usually go off in the weeds and I refactor things to try to make it less confusing.
That sounds useful.
Well, yeah, but then that's what we end up doing for the stream.
I mean, you could ask these people if they understand it, if it's confusing.
I don't know if they understand it.
How would we know?
I don't even know what it really means for them to understand it. Like, what do I want them to do with tinygrad? But then you're in this thing where you're starting to think about like people inside of your box,
Mm-hmm.
and I don't ever want to be there. Right? It's not like there's like a workflow. I mean, I guess for so many companies, this stuff's really easy because you basically just think, here's a person. And if I had complete mind control over this person, I know that I would want them to purchase a Pepsi and consume a Pepsi every hour of the day.
Mm-hmm.
And that would be success for the Pepsi Corporation. But what I want is people to do things that are outside of the box that I've put them in. Because if they're inside the box, I might as well just use AI.
Well, they need to understand what it is in order for them to.
George has gotten so zen.
Look at that. What are the chances?
What are the chances?
What are the chances? I wonder why that happened.
Yeah.
All right, interesting. I will leave you to it and order some lunch. Sounds like a nice quest.
Tell me when the you'll love Shanxi Magic Kitchen.
I'm excited about it. I'll bring it when it comes.
That sounds good.
We can have lunch with
get
our
a white rice
friends.
too. It's only $2. You can get a rice.
Anything else you want? Last chance.
Just that.
Okay.
Thank you. Source one in this case, this one is the GPU kernel. Is the GPU kernel that's going to be run. Kind of nonsensical still. You almost need like a better language to. Does this like kind of make sense though? It's basically the same as this. Almost everything in tinygrad functions as a rewrite of the UOPS. Hey, already ordered. Thanks. Cogen. You can see at this point we are adding 7, not 3 and 4. Actually, this stuff's always better to do on CPU. Oh, that is CPU. What? Oh, interesting. That didn't run the linearizer. I don't know. Like, does this syntax make sense? I mean, I'm sorry it's like kind of confusing to read, and we might want to put some effort into working on this. But yeah, so define global is a global buffer, and then we're indexing in with this special thing called GIDX. As you can see, we're loading from global arg1, we're storing into global arg0. Okay, so the function name, E4 means that it's an element-wise op. I'll add this here. Function name means is E4 element-wise op as opposed to R for reduce op. Four for the size, and for name deduping. Print name with debug equals 2, you'll see the 4 is yellow, meaning that it's upcasted. If you run with no opt equals 1, you get this code. And the 4 is blue. So we have a list of the colors, I believe, in kernel.py. Wow, like, okay, I'm realizing how completely confusing this is. Like, when people see, like, when we run something like Beautiful MNest, and you can see that, like, you see all these colors, and, like, they all just make sense to me, but I guess this is just nonsense for people. Blue is global, light blue is local, red is reduce, yellow is upcasted, and purple is unrolled. Green means group. Wow, I guess like this is such nonsense to people. You think Viz is more intuitive? Yeah. All right, ChatGPT, you're up. What follow-up questions do you have after reading this tinygrad tutorial? Think about how to approach it. Yeah, nice to know the colors and the letters, right? Like, it's the kind of thing that people just, yeah, like, I don't know. You're right. Is runnable, editable. whenever you see stuff like discussed, these are environment Oh, do you want to explore writing a custom op and gradient rules yourself? So like the rewrite rule that's actually doing that is here. Some people look at code. Oh, I should make this small again. Sorry. Multi is being worked on right now, but it's pretty stable. I mean, the multi examples haven't changed. From like a consumption perspective, it's identical. So like some people look at code like this and they're like, this shit doesn't make any sense. But like, it's dense and you have to spend time looking at it to understand it. But like, we're not optimizing for each line to be readable. We're optimizing for the whole thing to be readable. Like, this is our entire gradient library right there. And sure, you might have to look at it for 10 minutes, but like compare that to trying to find wherever the derivative of log is implemented in PyTorch. You can just like edit that and it'll like change the derivative. This isn't that good. I mean, I guess I don't really know what I expected. Now we go even lower and understand how the graph rewrite engine works. It's much simpler than what's in LLVM or MLIR. really know how that works. What you're saying, like this? Oh, cool. What? Huh? Wait, what? How do I, why is this doing this? No, you're right. How do I, why is this not like... Solved it by using a VMV? Hate VMs. Alright, well, this might work for somebody, but it doesn't work for me. I don't care. I'll just run it on the command line. UOps support normal Python operations. Why doesn't this work? I mean, I guess you want to use a VM. I should gain experience with, no, but that won't even like. before launching VS Code? What? Jupyter playbooks? Oh, here we go. The kernel died. Ent? Oh, what? I don't even know about that. I mean... Okay, cool. Great. This one runs on its own. T is not defined. I will have to redefine T. I think I would almost do this, write some of this stuff a lot differently if, like I knew that it was going to be run like this. It's kind of different, but I don't know. pattern matcher is a list of tuples. All right, so you want to write a pattern. Okay, cool. Okay, cool. So does this kind of make sense to people? Yeah, we'll have to retweet that. Tiny boxes are very good. Yeah, it's simple, and then like all the there were edge cases and there were foot guns, but I think that kind of like explains tinygrad. Does anyone have any questions? This looks like Haskell as a Python DSL. Yeah, kind of. It's functional. No, I mean, like Viz is, you should know about Viz once you've, Like here, so we can actually run this tutorial with Viz equals 1. I'm not sure what it's going to do since I won't be able to see some stuff. So like, yeah, you can like see the kernel, like here's 3.4. Here's that kernel getting written, and then like you can see down here in symbolic is where like, so that's the 3 and the 4. You can see that it's first rewritten to put the two consts in an add. That's like an associative rule, and then that's the const folding rule. This unroll thing, you can see it propagate through the graph here in the devectorizer. So that actually becomes the 4 stores and stuff. Yeah, I mean, this is beautiful. And once you like understand what these things even are, this is an incredible tool. Like each one of these boxes in the graph is a UOP. And we're working on, so this is mostly written by Kozalin in our Discord. And now we're working on making a whole new tool kind of like this, but for time-based visualization and not rewrite-based visualization. Yeah, and all our devices are the same. Like they don't have little subtle differences like the Torch ones. I mean, okay, there's like some differences. Like, sure, metal doesn't support long, but like, it's not like there's nothing we can do about that. That's fundamental to the device. Torch will be like, oh, well, I'm sorry, we don't support int8 convs on the AVX2 CPU type. And it's because we compile all the kernels on the fly. I don't know. There is like a lot to understand now. Yeah, we can see these. Where'd the 4 go? And it's gone. Yeah, like a profiler. I mean, we have a profiler, but it's janky. Where's the... Yeah, okay, I guess, yeah, you can see the kernels run over here. But yeah, it's like Perfetto based, and like, yeah, you can see this kernel, but this should ideally like link back to the visualizer. This is just Perfetto. This is a Google tool. We didn't write this. we're working on a different profiler. I think that like work's really going to start to pick up on that. And we're going to start thinking about like, yeah, because otherwise it's really hard to debug the scheduler. Also, yeah, you can just run with like viz equals 1. Most core concepts in the tinygrad can run to web-based graph rewrite explorer. Hopefully now you understand it. You don't want trainer fit. You think you do, but you don't. Like, I mean, if you want, like, read beautiful MNIST, right? That's the whole file. That's a whole file for an MNIST trainer. There's nothing you want taken out of there, trust me. Oh, we can almost get rid of this line. I have a bug to fix. But then we can get rid of the line. Like, that's a full MNIST trainer. Trust me, there's nothing else you want. If that doesn't make sense to you, you shouldn't be doing machine learning. Okay, well, that's today's stream. I am gonna go eat food. Well, I got 5 minutes if anyone has any tinygrad related questions. Hopefully this serves as an actual ramp. Hopefully people can follow this, watch this video. It's relatively short. We stayed on topic. We walked through the tensor level. And then we dove down a bit into the UOP level and saw how code is actually generated. And if you read this full rewrite to sync, all you're going to find in here, we'll have these like rewrite steps. This is just a little bit of syntactic sugar around just graph rewrites. So these are all the graph rewrites in tinygrad which do the generation, and they're just graph rewrites just like this one. So this is the strongest part, and if you understand how like this stuff can transform UOPS, you'll understand the entire tinygrad, and then you can view these things with viz equals 1. I'm happy that I explained the names to people and the colors, so hopefully that stuff's a bit more understandable. You know, how to do gradients. It's all just like the same transformations. Like you can read this code, you'll see that it's basically just, so this is using the pattern matcher directly. It's not a graph rewrite, but you can figure out why that is. You know that this was a real tutorial today because we made the font large. You know that I was actually trying to teach you things. I think that, like, the beauty of it is in its simplicity. Like, it's not simple in the sense of you can read each file and it's simple, but it's simple in the sense that that this is practically maintainable by a small group of very smart people. There's a lot of code out in the world that when you think about React and Kubernetes and these massive libraries, what they're doing is they are forcing you to think like Google or Facebook. If you can't break out of slavery by using the master's tools. It's a myth. People think that the Amish are against technology, and they aren't. Their problem with technology is not something inherent to technology. It's that if you buy a tractor from John Deere, you now need the John Deere serviceman to come into your community, and he subverts the ideology of your community. So that's the problem. Whereas something like a wheelbarrow, well, a 12-year-old could build a wheelbarrow. And a wheelbarrow is maintainable by the people in the community. So it's the same idea with technology, and this is the point of the tinygrad project. If we build something that is realistically maintainable by one or several smart people, I mean, you have to be smart, there's no getting around that, but no matter how smart you are, you can't deal with the complexity of a million-line code base. You can use tactics to wrangle complexity, and you can work on part of it, and maybe you can make it work for your use cases. But again, that's using a John Deere tractor and not using a wheelbarrow. We want to build a library where you use it and you be like, you look at it and you're like, well, I could have written that. I can maintain this. I can extend this. And it's the whole thing. There's not, oh, well, we link in this whole magic thing. We link in nothing. tinygrad has no dependencies, except sort of for LLVM. But even that one's going to be removed in due time. So the default install of tinygrad actually installs nothing. These are just for testing and docs and stuff. Why is WMMA not a rewrite rule? That's actually a really good question. Because we're not upcasting warps on GPUs, and this is going to be fixed. So basically right now the warp is being treated as something that is outside of the graph. So that's why it's these hacks in kernel.py. I would put a big bounty up if someone fixes that. If someone can like reasonably integrate warp upcasting, it's almost doable. I mean, I had to do a lot of this stuff for the DSP. What is a warp? See, that is not a good question. That shows that you know nothing about GPUs. Is trying to port an existing PyTorch-based model to tinygrad a good way to learn? Yeah. Should you expect better performance someday? You should expect better performance today. So if you run with beam equals 2, depending on where you're running, there's many places where tinygrad is faster. if you're doing NVIDIA, maybe not. If you're doing these like hyper optimized AMD things like Stable Diffusion, maybe not, but it's not that far off. But in general, just if you're doing pure unoptimized stuff, so like we have a HLB CFAR implementation in here. And if you run it with beam equals 2, it's about 20% faster than normal torch on AMD. Actually, that's training too. So you can try it, and it's a little bit finicky to get the performance sometimes. Sometimes it's really easy. Sometimes you just do beam equals 2 and you wait, and then it's fast. Yeah, but no, I think that's a really good way to start playing with it, implement things. The point here is that tinygrad really is your library. You can fully own it and understand all of it in a way that you could never do with PyTorch or JAX, because there's so many layers. There's so much complexity that it's designed for, really for massive companies. Only massive companies are able to wrangle that much complexity. You as an individual can use the library, but then you are a consumer. The point of tinygrad is to get you out of the idea that I'm a consumer. Oh, I consume CUDA, I consume CUDNN. No, you don't. You don't consume any of that. We don't use any of that stuff. tinygrad consumes nothing. tinygrad is yours, and it's 13,667 lines, and that includes things like a full AMD driver. There's a full AMD driver in here. There's soon to be a full NVIDIA driver. So you can remove the AMD driver from the kernel, and you can just use what we have in here. It like downloads all the AMD registers from the internet and parses them out here. Downloads the registers. Here it's configuring the PCIe bars. This is to use it over USB. This is how the stuff works over USB. So it really is a library you completely control. Does tinygrad make money? Yeah, buy a tinybox. Yeah, that is the 1,000-line rule. Well, it's gotten a little bigger than 1,000, but hopefully we've kept the complexity well managed. I gotta go. I got lunch to go eat. Thank you all for watching today's stream. Hopefully this was a very noob-friendly stream. Yes, I'm coming. Dude, yeah, we're almost done. Yes, I'll miss all of you too. If you missed what food we got, you weren't here for the beginning of the stream, you can rewatch it on the VOD, but only if you're a subscriber. When new blog? Why don't you ask me when the new jailbreak's coming out too? Of the heart, thank you. I might be on a podcast this week. You might see me. Torch Linalge. Yeah. Well, it'd be great to implement some of those things in tinygrad. No, it's not Lex. It's no. Okay, everybody. Thank you for watching today's stream. Go out and use tinygrad, but don't consume tinygrad. That's kind of my whole philosophy. That's my philosophy with comma too. If you are a consumer now, you're going to be a consumer the rest of your life. Stop being a consumer. That's if you look in the comma.ai subreddit, you see me argue with people, and what these people want is a consumer mindset. These people just want to be handed something so they can consume it. And I'm not going to actively go out of my way to say, no, you absolutely can't use it like that. But I'm not here to cater to that mentality either. People are surprised by that. People are used to other people catering to that mentality. But I want you to realize that if you're a consumer, what's going to happen to you is that you're going to end up wireheaded. Whatever the biggest, baddest advertising manipulation agency that decides to make you their consumer, I mean, another word for that is slave. And I don't know, but I don't want to grow up to be a slave. I don't want my kids to grow up to be slaves. But if you want to be a consumer and you want to consume, you can. You can consume right up until the day you die. But I am telling you to make a different choice. But I'm not telling you to make a different choice, because you got to find your own path. I'm not, there's no path to not be a consumer. That's the whole point. The world needs to change, or we're all gonna die. You're gonna die, I'm gonna die, everyone's gonna die. Unless we make a change today. And that's why I need you to sign this petition in order to grow bananas right here in America. Thank you for watching today's stream. I'm going to consume lunch.